um, let us say we have a satellite which is revolving around the Earth. Let us say this is the orbit of the Earth. This is the satellite of mass m, and it is revolving in this direction with orbital velocity v0. This is the center of the Earth. This dark line indicates the Earth, and this dotted line indicates the orbit of the satellite, right? We have taken a case wherein the satellite is revolving in an orbit which is very, very close to the surface of the Earth, right? That means h, right? This is RE, this is RE, and this distance is h. H is very, very small as compared to RE. H is very, very small as compared to RE, and therefore h will be which tend towards 0, and so we'll take the value of h as 0. Now, what is the energy possessed by this satellite? Quite obviously, it has potential energy because it is closer to the surface of the Earth, and since it is moving with velocity v0, it will also have kinetic energy. So let us try to find out what is the energy of this satellite. As far as potential energy is concerned, it is minus g me m upon re, which is the equation for the potential energy of any object on the surface of the Earth. Now, since the satellite is very close to the surface of the Earth, we'll take its potential energy as minus g me m upon re. So I have the equation for potential energy. As far as kinetic energy is concerned, kinetic energy will be half m v0 square, right? Mass of the satellite and speed of the satellite v0. In an earlier derivation, we saw that v0, orbital velocity, right? Or the equation for orbital velocity is square root of g me upon re plus h. Now, since h is 0, this formula will be v0 will be equal to square root of g me upon re. Right? And if I use this particular value in the equation of kinetic energy, right? Kinetic energy is half m v0 square. That means g me upon re, right? And therefore I'll get the equation half g me m upon re. So this is the equation for kinetic energy, right? So I have equation for potential energy, I have equation for kinetic energy, and therefore the total energy will be the summation of potential energy and kinetic energy, which will give me minus g me m upon re plus half g me m upon re. And if I solve this, I'll get minus half g me m upon re. So I have an equation for total energy of a satellite revolving very close to the surface of the Earth. Total energy is given by minus half m g me m upon re. What does this minus sign indicate? The minus sign indicates that the total energy of the satellite, let me come back to this diagram over here. What indicates that the total energy of the satellite over here is minus g me m upon re, and if I try to show the gravitational field of the Earth, right? Let me say that the satellite is over here because I have more space over here, so I can show it clearly. So the total energy over here is minus half g me m upon re, and we know that the total energy at infinity or outside the gravitational field of the Earth is 0. So here t is equal to 0, here t is equal to minus half g me m upon re. What this means is that if I want this satellite to kind of go towards infinity, then I will have to give it energy equal to half g me m upon re. So if I give this satellite energy equal to minus half g me upon re, then it will be able to go outside the gravitational field of the Earth, right? Because this is minus half, so if I add half g me m upon re, this is the energy that I give this, then it will be, the sum will become total and will be equal to 0. The total energy here is 0, so the object will go towards infinity. Right? That's what the minus sign indicates. Right? Okay. So if I am not able to give this energy, right? If I am not able to give this energy, what will happen is that the object will continue to move around this in this particular orbit. In other words, it is bound in this particular orbit, and therefore this energy minus half g me upon re, the magnitude of this energy is also known as binding energy, because this is the energy with which the satellite is bound to the Earth. Binding energy is half g me m upon re. So we have obtained an expression for binding energy of the satellite, the energy with which the satellite is bound to the Earth, right? is equal to half g MEM upon RE. Thank you.